Everybody, we're just all right. We're just going to, if you're joining, we're just going to give a few minutes or a minute or so just for people to join the call, and then we'll get started. So. Nice to see you smiling for a change, Jeremy. No. See, I can be cheeky as the host and you're not allowed to retaliate. Okay, folks still coming in. Okay, so I think folk are still coming through, but we'll make a start here and get going with our Techcast. So saying that, I've lost my notes, but there we are. Okay. So first, very quickly, who am I? I'm Roger Cressy. I'm one of the founders of the Cubics Group. We're an Oracle Platinum Partner company, and we operate around the world. We implement and develop ERP, EPM, and analytics solutions alongside our customers. But today is about ANDOUC. I volunteer alongside an amazing group of people in various capacities with the Analytics and Data Oracle user community. And it's a privilege working with this bunch of people. So today we're having a talk by Jeremy Simmons, a colleague of mine, and it's the topic is unlocking the hidden value of ERP data. All right, so just some quick housekeeping and some news before, some notes before that. You should be aware we've got our Techcast demo days coming up from October the 12th to 14th. This is 3 hours per day of sessions broken up into machine learning, spatial, and graph and analytics. There is a lot of good content coming through. Please note as well, if you're a partner company or someone wanting to get some awareness out there, we do still have some sponsorship opportunities available for those Techcast day sessions. And then just to let you know that Techcasts like today are a regular feature. We try to do them every other week. So our next Techcast after the full session of the Techcast demo days is on November the 4th. And that's a session by Joe Darshewski, Oracle Machine Learning in Propensity to Buy Modeling. A few weeks back, I hosted a Techcast with Patrick Wheeler and Ashish Jain, and that was talking about Essbase on OCI integration with Autonomous Data Warehouse. That was a lot about Essbase Federation. Very interesting thing. If you do have an interesting topic for us to do with how you're using Oracle technology, we'd really love you to submit an abstract on our website. These are evaluated by our Techcast subcommittee, and you can have an opportunity to share with us. We'd love to hear and learn from you. Ways to connect with us. So, sorry, I've gotten the wrong order, haven't I? Sorry, Jeremy. We do have merchandise now as well, and they're the brainchild of Abby, one of our volunteers. She's created some not common merchandise, some unusual merchandise, which is, I think, a cut above what you see in most places. So go and have at it. There's some quite nice things there. How you connect with us, we've got a growing way of communicating with us. If you use any of these, we send out a newspaper which actually gets generated overnight and goes out every morning. You can get to us on the Slack channel. We're on LinkedIn, Twitter, and Facebook, and these links will be posted in the chat by Carrie if they haven't already. Next slide, Jeremy. Is that onto yours? Yeah, okay. So really at this time, just one more thing to say. If you do have any questions, please don't put them in the chat. Put them in the Q&A section at the bottom. Those I will keep a monitor. I'll monitor those, and I will then highlight them. If it's worth asking the question in the middle of it, I might prompt Jeremy with that. If not, we'll answer them at the end. So just to tell you a little bit about Jeremy before I hand over to him. He's a business and technology consultant with over 20 years of experience. Yeah, he's almost as old as me. In delivering value to organizations by closing the gap between business needs and IT capabilities. So he takes a very hands-on approach to delivering technical work with a strong ability to speak to and gather C-level requirements and then translate them into successful projects. It's a real privilege to work alongside him. And he's also a man after my own heart, where being buried in the guts of a car engine makes him happy. Porsche's his car of choice, which is a bit rich for my blood. But anyway, so with that, Jeremy, I'll hand over to you, my friend, and we look forward to learning from you.
Yeah. Thank you very much, Roger. So, and thanks for that really good introduction. So, as Roger said, my name's Jeremy Simmons. I'm the Director of Analytics and Data Engineering at the Cubics Group. And, my focus mostly is working with customers on a day-to-day basis to solve kind of the most challenging data engineering issues in the organization. And that scope of data engineering has sort of changed and evolved over time. It's gone from what was historically like ETL type work to really complicated data integrations and scripting and other avenues to move data around the organization. So this topic of getting value out of your ERP data and the challenges that are associated with that, I think is a really important topic to me. And it's a lot of what we see on a day-to-day basis with our customers. So in terms of an agenda for today, probably about 30 minutes of slides, something along those lines. And it'll focus on what do the ERP data silos look like. We'll get into a little bit of a case study of a retail customer and what their particular challenges were. Talk about how do we solve some of these integration complexities? What are the methodologies that are being used and are successful now in solving that? And then briefly touch on sort of the modern data platform and also how that can enable data monetization in the organization. So what is kind of the ERP value problem that's out there today? So as many of you probably have experienced, ERP implementations in organizations are very complex. Gartner estimates that something like 50 to 75% of all ERP projects fail to meet their objectives. Even when they are successful, they often exhaust the resources of the organization. They exhaust the budgets, go over budget quite often. And that leaves management in a position where they're really searching for return on investment from their ERP implementation. They've invested in this, they've done a 6-month to a 2-year project, and now they want to get value out of it. They want to use it organizationally. And ERPs tend to get into what we call a maintenance mode then. This is a lockdown system. We're not trying to change it. We're not trying to re-architect it. we just finished an implementation, or we've had an implementation and we don't want to do another one, there becomes an unwillingness to upgrade or to modify the ERP after it's been implemented. But despite that reality, business evolves. Business tends to move on very quickly behind the scenes. Acquisitions might occur, mergers happen, divestitures, new products come along, new development happens. And what we find is, because there's such a rigid search for ROI, that the ERPs don't evolve at all. And the business and the other parts of the organization start looking for ways to get the answers to the questions and these new, mergers and acquisitions to deal with. How are they going to handle that in an environment where no one is willing to sort of upgrade or modify the ERP? And what we've seen historically happens in organizations is essentially what we call shadow systems pop up, right? Spreadsheets, other ways of working around the rigidity of the ERP environment. Another problem that occurs is that ERPs tend to be very siloed. And a lot of this comes down to how the ERP was implemented. Was it a single vendor implementation, meaning you have this sort of monolithic stack on premise or in the cloud where you've gone with a single vendor? Or did you choose sort of a loosely coupled federated environment where you maybe went best of breed and you're pulling HR from one system and finance is another system? So quite often there are multiple vendors involved. Sometimes we see a giant legacy stack, but it's not too common anymore. And more often than not, we're seeing several federated ERPs being involved in that environment, in each containing their own data and their own sets of problems. So when we look at those sort of data silos and the legacy vendors with the sort of monolithic ERPs, they're typically on premise. They're very highly customized to the business, right? Low level access to the data involves getting into very complicated underlying schemas. If you look at a system like SAP, for example, the underlying basis for it and its data is really challenging to work with, to the level that most people aren't ever accessing the data at the schema level because it's just too challenging to integrate with. When you've got this single on-premise kind of vendor, you've then got issues with how do we integrate with other external sources? How do we deal with cloud and other cloud vendors that are involved? And you've got the siloed reporting tools that come along with those particular vendors. And we look at a more modern sort of SaaS-based ERP, we've got challenges here also. This isn't the answer to every question. If you look at Workday or NetSuite or any of these types of vendors, they're typically cloud-based, but because they're SaaS, there's constant change. They're often implementing quarterly changes at a minimum. Sometimes patches are coming on a monthly basis. When you do a best of breed, that's great, but then that also usually means you have several of these vendors. So you'll have multiple vendors involved. Each of those vendors then implementing their own interfaces for integration, their own APIs. Those APIs are under constant pressure and change with different components being added or deprecated or changed all the time. And you have multiple reporting tools also involved in these environments. So how do we deal with that, right? How do we deal with this sort of implementation maintenance mode implementation fatigue that happens, because the leadership is going to want to avoid change. They're going to want to avoid doing projects and upgrades as they try to get value out of the ERP, and business is going to be pushing the other side. They're going to be pushing for new systems and new ways of integrating, and mergers and acquisitions are going to force change. And we need to avoid sort of the morass and the shadow systems that can pop up because of this. So if you look at this example on the right-hand side, this is not an uncommon kind of scenario that we run into, where you'll have many, many different data sources on the left, all trying to be integrated through some data warehousing utility with other integrations on that. Massive spreadsheet systems being built in order to try to just run the business. And, this happens over the course of 1, 2, 5, 10 years of business. These types of systems get built up. So the data engineering challenges that are really associated with this, if you look at the legacy side, is the complexity of those underlying schemas. How do I get in there and get that data? How do I get it out so I can get some value from it? Most organizations will have pretty strong security concerns about direct access. If I'm not going through some kind of API layer and I'm going direct to the data, what does that mean from an organization standpoint? Who has access to what? And then there'll be challenges around the integration technologies that you'll be using. Is it ETL? And is that going to be fast enough? And does that give me real-time data at the level I want it to do the reporting that I want to run the business? If you're an organization that has SaaS-based ERPs, then you're struggling with a different set of problems, typically. Limited access because you don't have that. Because it's a SaaS vendor, you're not given all of the sort of back-end rights and capability to the data. So you have to work with their APIs, and those APIs are often complex, mutating, changing on you all the time. Most organizations resort to what we call report-driven data exports. So they'll use the reporting tools that are built into these ERPs. They'll create CSV files, they'll extract them, and they'll make a scheduled job and push it to another system. And so that's the level of integration that often occurs in these environments. So let's talk briefly about a case study here. This is a major American retailer. So this company was a single brand, started in the 1970s. They grew to well over 1,000 stores in the US, Canada, and internationally, Mexico, Hong Kong. They had a legacy ERP system that was really implemented in the early 2000s and is the epitome of what we would consider in maintenance mode. They're no longer investing in it. They don't want to change it. They probably need to do a new ERP project, but there's really no feature function capability of a new ERP that they've found that would make it worth their while to invest in it. So they've stuck with it, and it's a traditional general ledger. There's a legacy retail management environment that's attached to it. So what's happened as they grew over these years to 1,000 stores is they began to change the way they're doing business. They started adding brands. They added them via acquisition. They invented new brands that they wanted to run both organically. They created new channels of how they do business, right? The web emerged as a way for them to do business. They created things like direct shipping from the web to customers. They created channels like store to door, where you go in and order something in the store and then it's shipped to your house. So these different brands, these different channels emerged, and they started to ask questions of the ERP that they couldn't answer. They started to ask key questions like, what's profitability by brand? Well, the ERP had no reference or no capability to understand how brand worked in their organization. So they solved it themselves. And they solved it by creating this massive spreadsheet system that pulled data from all of their legacy ERPs and various sources, plus the new systems that had come up to handle like web analytics and retail management. And they were struggling. They were struggling to get accurate, correct answers. They were struggling to really know what the true brand P&Ls looked like. They were struggling with the time it took to manage all of this. They were spending hundreds of hours managing the spreadsheet system, manually updating and pulling data down. And they weren't really able to unlock the value of all the data that they had. So how did we solve this problem? Well, we came in essentially and we built them what we consider a modern data platform. So in a very simplistic view of it, we took all of those various sources that they had out there in the environment that they needed to do brand P&L, their legacy general ledger, all of their new web systems. We added a data movement architecture that was consistent across the organization. We loaded it into a modern data platform, and we'll get into more details about what this is and what this means. And then we gave them a consumption layer. We gave them a consistent view of their data. And we left the consumption layer in spreadsheets because that's where the finance team was comfortable. But now, instead of manually maintaining it or pulling it from many sources, they were doing it via a centralized system with a single point of view of how they did that. So what were the results? And more realistically, what did the system look like? We took them from 1 week of data management and manual exercise down to 15 minutes. And we were able to do that by putting the platform in place using this new technologies that would allow them to get to a consumption layer based on all of these various source systems in a very effective and efficient way. Simplified the way they do planning. Now they have a master reporting cube in their organization, and they can do all of the sort of financial slicing and dicing that they want to be able to do organizationally. So let's drill a little bit into how the modern data platform concept works and how that helps you solve this sort of integration problem that you have out there organizationally. So going back, if you look sort of historically at what the data engineering function or the ETL function looked like in sort of the world of the early 2000s into sort of the late 2000s, we were taking source data, copying it from the sources, putting it into a staging area. Then we would go through this transformation mechanism where we would convert it from whatever form it was in the source systems into a dimensional data model, typically. And this sort of legacy design pattern really took months, if not years, to develop. It takes a long time. You have to take either a top-down or a bottom-up approach when you're doing this. You either have to go to the source systems from the bottom up and look at all of the different subject areas that they cover and all the different data elements and try to build a data model that supports all of that. It's kind of like boiling the ocean. It's a very difficult undertaking from the bottom up. The other approach that was taken was to go from top down. It was to ask the business what questions they wanted to ask of the data, and then go out and find the source systems that had that, model them, and build all of the structures that people wanted. But again, you never got the business value until you got to the end of the process. You had to fully build the model. You had to deploy it in order to really garner any business value. And when you took that top-down approach, you now had a fixed set of questions that you could answer. And as soon as the business evolved, the data was no longer relevant, or maybe you were missing key questions and you had to start the process all over again with months or years of development to sort of answer the questions that you wanted to get to. So a modern design pattern has emerged over the last, say, 5 to 10 years now that makes this much more successful and an easier process for businesses to work with. And in this case, we're leveraging a few components that we'll talk about, but essentially we're moving the business value to much earlier in the process by allowing the source data to come into the modern data platform as raw data. And we're able to work with it as analysts and as data scientists and as, analytic power users earlier in the process. So the tools and the underlying platforms now allow you the horsepower and the capabilities that you need in order to be able to deal with the data in its rawest format. So it becomes sort of a data lake, if you will, but not necessarily a data lake of the data that you want to have there. And then users can now get in and build and do data prep and refine their own data sources. And then ultimately you can build what we call a golden layer, which is what is then exposed out to the business and to the broader community. And this is your statutory reporting and your other reporting that you want to commit out into the larger business or maybe out into the public world. So we take that and then we consider the emergence of what we call cloud-based SQL analytic platforms. So in this case, we'll talk about Oracle Autonomous Data Warehouse, but it has a few key components to it. Number one, it has elastic CPU, elastic memory, and elastic storage. So why is this important? Well, in the past, as in an organization, we had to kind of know what questions we were going to ask and how much horsepower did we need and how big the data was going to be ahead of time, because we had to invest in data centers and servers and storage and CPU that would support the analysis that we wanted to do. Now with the emergence of these cloud-based elastic environments, we don't have to ask that up front. We can scale the environment to meet the needs as the platform grows. So we can make a minimal initial investment of a few $100s even, or a few $1,000s a month. And as the platform grows and becomes more successful and garners more use in the organization, we can scale the environment up. The other thing that comes along with these environments is object storage. And object storage is extremely low cost and supports less structured data formats, if you will. So we don't have to worry so much about exactly how the data is formed in the ERP. We can deal with data that's coming from interesting or less structured formats than we're traditionally used to. So we take these two pieces that we've built here and we combine them together. We take the modern design pattern, which is essentially the data lake design pattern, and we combine it with a cloud-based analytic platform like Oracle Autonomous Database. And essentially we've got the modern data platform. That's the difference maker that's changed in the last 5 years over legacy data warehousing and legacy integration. That is the difference maker in how companies are doing this successfully today. So this pattern allows us to essentially build an environment where we can avoid re-architecting the ERP all the time, because now we have a place where we can bring together these new sources. We can bring together the ERP data from multiple acquisitions. We can allow a place where we can sort of answer questions at a level which will avoid the sort of uncontrolled growth of shadow systems. And that's a key aspect of how we keep that from happening. So if you drill in a little bit deeper, and this gets a little more technical, what does a modern data platform really look like under the covers? Because autonomous data warehouse itself is just an empty shell, right? It's not anything more than a database. So you have to organize some of the components of it in order to make it into a system that will be effective for avoiding those shadow systems. So these are some of the key components that you need to have and consider. You need to have a raw space, a landing area for all of the data in your organization, whether it's ERP data, whether it's files, whether it's machine generated data or other clickstream data. You need a place where that can land, and the organization and the scientists and the power users can have access to it and can use the tools that are available to them to analyze the data at that level. They can ask questions of the data here that the organization wants to ask. They can come up with new ad hoc analyses and do it right here without any additional physical structures having to be built. They can do that now because we can harness the power of both low-cost storage and elasticity in our processing power. So I can run a one-off, very giant query across multiple tables that have come from multiple ERPs, and I can crunch through that and I can find the answer to a question. And once I found that answer then, and we know that that's going to have value to the business, then we can move that to what we call the data prep phase. So now this is going to be a recurring question that's going to be answered all the time by the organization. It's going to be asked a lot. We take it, we bring it into the data prep phase. We work it through that data preparation process, which may mean creating a views or creating additional data movement, ETLs, and other things in order to make the data more accessible. And once we've got that done, it lands in what we call the refined space. And the refined space is ultimately those sort of final data sets and the final finished structures that you're going to expose out to the broader community. It's also the place where you're going to combine your refined data with other metadata. Maybe you have organizational metadata like product hierarchies or account hierarchies. Maybe you have industry reference data that you're using. Maybe you have a customer hub or some other master data management process. So this is where you mix the data with that customer hub, join it together, and have that sort of master place. The advanced analytics sandbox is extremely important. This is the place where your data scientists, your power users, your analytic workers are grabbing the raw data and working it through that data prep phase. And it's key because a lot of the modern tools then need to have access to this and want to have it in an unstructured way so that they can ask questions that aren't pre-answered by the data, right? We want to be able to allow them to innovate and look at new things like, what is our brand P&L? Well, we've never asked the brand P&L question before. How are we going to do that? And using the raw combined with data prep in that advanced analytics sandbox is essentially what allows us to do that, create a feedback loop, and ultimately land that into the refined area. Then for some organizations, they'll extend this with streaming. And this is kind of a specialized use case, doesn't happen everywhere, but some organizations have, say, like Internet of Things type products or other components out there in their market, maybe clickstream analytics or other web analytics, and they want to get a more real-time view of that in their reporting and consumption layers. And so we don't want to leave them out and have that be a separate path. So we need to be able to support messaging and streaming of data in a near real-time fashion from our source systems. And some of those challenges then involve how do we do that data movement, which can become a more complicated scenario. But we want to be able to support that in any modern data platform as well. And then ultimately the consumption layer moves from the typical stuff that we had seen at the top, which is web-based BI tools and mobile and email-based reporting, to this new breed of exploratory intelligence, right? Where you can do refining of the data and discovery, and you can get to that data mining goal that we always want to get to, but that is very challenging to do in a data warehouse where the structures are very rigid. Now you really have an opportunity as a data scientist or an analytic worker to really mine the raw data, looking for and trying to answer the most important questions of the organization. So let me give you a quick example, real world, of kind of a finance scenario and how they would implement a modern data platform and why it would be valuable to them. So you can imagine an organization structured something like this. Maybe they have a parent company that has a large centralized ERP. They've, through acquisition, acquired several smaller firms, but they don't want to or have not had the opportunity yet to merge all of those businesses into the centralized ERP. And you've got a financial close and consolidation system that needs data from their entire organization in order for them to produce, a month-end close process and a month-end consolidated view of the business. So with this modern data platform concept, you now have a landing place to pull in all of the data from those various ERPs. Maybe they're not directly integrated yet. Maybe you have to land some data files. Maybe your centralized ERP is fully integrated with its backend, either APIs or ETL processes. You get it into this centralized platform. You pull in the very important finance metadata, because in the finance scenario, metadata is really key and often quite difficult to maintain and manage. Count structures, products, department hierarchies, all these things are managed by finance teams and need to be integrated with the ERP data in order to produce the correct final reporting results. So that comes together inside the modern data platform. Again, the data movement tools then move that to financial close, and now you have a consumption layer. And so this creates a very clean system that allows you to expand your business. It allows you to go through divestitures or additional M&A, or to do changes to how this business is going to work. Take these ERPs and ultimately integrate them into the central ERP. And by implementing this centralized modern data platform, you're buffering all of the downstream finance work from those changes. And so it creates a lot less disruption in the business, gives you a platform, and avoids the finance team from having to create an end around where they have to now have a one-off where they throw a file into their financial close system because they don't have a place to put it. It gives them a clean, regulated place to work. The other added benefit that we're not showing here is now all of this data is in that modern data platform. And now other user communities or other parts of finance have a centralized place where they can go and do analyses on that data and look for other interesting facts and components. So by solving the financial close path, we've also created collateral benefit for the organization. And oftentimes we see these start as small departmental level solutions that then become the answer for the larger organization, because they see that this is the right way to implement. It's an effective strategy for this department, and they take this design pattern and these technologies and they deploy it out to the larger organization over time. So kind of the last steps here before we summarize is a quick thought on how the modern data platform helps you enable data monetization. Now, the value of this will kind of depend on your particular organization and the types of ways that you interact and the data that you bring in. But if you think about it from the ground up here, foundationally, an organization needs to be able to cleanly move the data. They need to be able to get access to data and pull it out. And those quite often are challenges. But if you focus on the rapid ingest of data, automation, and flexibility, you'll be able to get that data into a modern data platform very easily, because you're not trying to manipulate the data or apply business rules or change or cleanse the data. You're landing it essentially into the centralized platform. So once you've done that, you've got it in this modern data platform. Now you have that raw data area, the refined, and that sort of data design pattern we've been talking about. Now you can layer on what most organizations want initially, which is dashboards and analytics, right? And drill the detail, reporting, visualization. These are all of the things that can come from having done the data movement step and having built out the modern data platform. You really have a clean way, a correct way to do that. And then organizations start to get to the next step, which is often talked about these days, but very difficult for companies to get to because they don't solve the foundational issues first. They try to jump right to the ML, the augmented analytics, and the artificial intelligence step. It's difficult to get to that data science if you don't have a place, a data prep area, a location for those scientists to do that work and for those analytic power users to do that work. So if you don't build this sort of baseline, you'll be challenged to get any effective results from this. And then this is where the monetization really starts to become relevant, because you can move potentially from not only internal value, where you're finding interesting things, you're finding ways for the company to save money, be more effective, have less downtime internally with your analytics and your ML. But now you can start to move towards benchmarks. And if you're in an organization that has data that has value in the marketplace, you can take those benchmarks and you can start to use them outside of your organization. Maybe you can sell them as a product. Maybe you can package them up and use them to create reporting that has value to other organizations. We see this a lot in organizations that we work with. There's a particular grocery retailer that we work with, and they have lots of sales information that they're able to monetize back to the various retailers about what shelves and how many and what their competitors are doing with that same shelf space. And so having built a foundation and then gotten to some of those advanced analytics, they were able to create sort of the benchmarks and the industry standard metrics that allow them to take advantage and sell that data out and back into the market. So the modern data platform, I think, is really key in order to be able to build a foundation that allows for this data monetization as we move across the maturity and across time. Okay, so let me just summarize, wrap it up, and we'll get to the questions. I think ERPs have a wealth of data. It's waiting there to be unlocked. But getting to that can often be complex, and daunting. The key is you want to avoid the shadow systems. You want to avoid organizations end-arounding the complexities of the ERP. And in order to do that, I think the modern data platform concept and design pattern is really a solid way, a really effective way to, to implement and avoid those shadow systems popping up, and allows you to really decouple the ERP from the business and minimize the impact organizationally.
So I think we're about time, Jeremy.
Yep.
There have been a few questions which I've kind of been answering on the side. One thing Marcelo Proano is saying that he still runs into the issue of performance and the architecture to copy a lot of data to begin with into our raw area. So do you have any comment on that?
Yeah, I mean, data movement capability is really important. I mean, we're talking a lot about the data platform, but this idea here of the data movement tools and how you do that is a non-trivial subject, right? I mean, it's a whole different presentation to kind of talk about the most effective ways to do that. I think the key is that we need to do it in the rawest and least transformed way. So replication utilities, copy utilities, doing your ETLs that are one-to-one, meaning you don't try to do any kind of data transformation. You essentially do the E and the L and leave out the T and get it into the modern data platform. And then you have the horsepower to do the transformations in the modern data platform. So the other thing is, a lot of these can be seeded with bulk data initially, and then you move to incrementals after that. And, the ERPs are changing, but they're not changing at a rate that the incrementals are massive. Now, if you get into clickstream or log files or machine generated data, then we have a different class of problem that we're dealing with. But from a business system standpoint, data is not often changing enough that the incremental changes are unable to be managed.
So I think we're at time. We've answered. Oh, hang on. I see one more open question. Let me just see what that is. Michael Sullivan. So Essbase replaces the ad hoc shadows. Yes. So I mean, essentially, that ad hoc sort of spreadsheet system that gets created that is subject to all the vagaries of maintenance and error and all of those things. Those are now actually retrieving their data directly from Essbase or wherever, but Essbase and planning specifically, so that it's all number one, permissioned, only the right users can get at it. But number two, it has already been subject to all of the validation and data checks that are required for us to know that the data is verified and accurate.
Yeah, very much. The modern data platform becomes the staging area for things like Essbase cubes and planning, because the data has been refined and has been brought together into one location, and then it makes it much easier to build the effective cubes that you need for reporting, and then that becomes part of your consumption layer, especially on the finance side, where SmartView is a really well understood and well used tool in those scenarios.
Jeremy, thank you very much for your presentation. It was really good insights. I hope everybody's enjoyed that. Don't forget to register for our Techcast demo days. We look forward to seeing you again. And once again, Jeremy, thanks. Great presentation.
Yeah, thanks everyone.